Today we are going to learn about analyzing the insulation of a steam pipe using MS Excel. This is the problem statement that we have at hand. We have a steam pipe which is having a diameter of 100 mm. It is not insulated and the length of the pipe is 100 meters. The steam supply pressure is 10 kg. We have to find out the savings possible when this steam pipe will be insulated with the help of an insulation having thickness of 65 mm. The boiler efficiency in this plant is 80%. The cost of furnace oil is 45,000 rupees per ton. Calorific value of the fuel is 10,300 kilocalorie per kg. Temperature of the surface without insulation is 170 degrees Celsius and after insulation it will be 65 degrees Celsius. Ambient temperature is 25 degrees Celsius. This problem will be solved with the help of these mathematical steps. First, we will calculate surface heat loss using this formula 10 plus Ts minus Ta upon 20 into Ts minus Ta. This basic methodology is generally used by energy auditors when they are doing field assessment during the practical energy audit. Then we will calculate total heat loss per hour by multiplying surface heat loss with area. Then we will calculate equivalent fuel loss. Then how much money is getting lost due to this insulation being absent on the steam pipe, that we will calculate. But the first and foremost the question is, why use Excel? Particularly when we are mechanical engineers. So remember, Excel is a very important data analysis tool, and that's why engineer from any branch should be able to use Excel at least up to the basic level. In any industry, in any system, process, equipment, a tremendous amount of data is generated. Analysis of this data is very important if we want to get important insights about the behavior of the system. Only with this analysis we can obtain detailed insights and we can improve the system subsequently. Hence we have to use Excel because it is one of the simplest tools. Then we will create a program in Excel. Now this program, why is it necessary? Because it will help us for parametric analysis. Parametric in the sense, for example, in this problem the pipe diameter is given 100 mm and length is 100 meter. But if there is a second industry which has 250 mm diameter pipe and the length of the pipe might be 370 meter, in that case again same analysis will be needed to be done. But if you have a program ready with you, that second analysis can be done in a short period of time. Also you can check the effect of various parameters, and that's why you should do that program in Excel. Now to start with the program, I will create a systematic table that will help to sophisticatedly write down all the given entities so that you are finally able to give it the necessary mathematical treatment. So the first parameter of the table will be whatever is the parameter which is to be analyzed or detail which is to be studied. The second will be symbol. Now Excel will not understand anything from the symbol. It is for our convenience, our understanding. As we can see, this column is overlapping, so I will select that particular cell. I will go to the header of this particular column. This partition symbol is there. I will double click, so the column size will be automatically adjusted. So parameter detail, then symbol, and then I will write value and then unit of it. So the first parameter is actually the given data, just like we do in any mechanical engineering problem. First of all, we will properly organize the given data. First one is pipe diameter. The symbol that we will be using, it will be diameter of pipe. So then what is the value of this diameter? 100 mm. Unit is mm. Again Excel will not come to know that this is the unit. For Excel this is just the text. Excel is concerned with the numbers which are present there. Second thing, we will use meter everywhere, so we have to convert this mm into meter. So how to do that? We know that we can divide it by 1000 so that we get final answer in meter. So we need to tell Excel to do this conversion for us. So let us tell Excel with the help of this small command equal to this particular quantity. I have selected this quantity with the help of my mouse key, or I can select it with the help of my arrow key. Any cell I can select. In this way, I am telling Excel that whatever is the value in that particular cell, cell number C10, C is the title of this column, while 10 is the row index. So this C10, whatever is that value in that particular cell, divide this value by 1000. This is my requirement. And then I will write meter. Now when I am writing meter, it is showing that there is already one suggestion coming from Excel, because somewhere in that same column something about is written, and we don't need that, so I will press backspace. So only meter is there. My job is done. My value from is converted to meter. Next parameter of given data, I will just mark this as header of my table. Next parameter is length of pipe. It will be indicated by capital L or small l, choice is yours. The value is 100 and the unit is meter. No conversion is needed. Steam supply pressure is not necessary for us. It is not part of our calculation right now. Next entity is thickness of insulation, which is given to us. So I will use a simple symbol T insulation. The thickness is 65, unit is mm. I am using tab everywhere. The benefit of tab is that now if I press enter after going to the last cell of my row, this using the tab will directly take me to the first cell. So now if I press enter, now it has taken me to the first cell. Here again I can observe that this text is getting overlapped because of the column. So I will select the cell, I will go to the partition symbol, and then I can auto adjust my thickness of column. Then T insulation. Afterwards, the next entity which is given is the efficiency of boiler. For this I can insert a symbol of eta. So insert symbol. Here I can find out in the Greek letters somewhere there is this eta symbol. So I will insert it. I will close this. Efficiency is 80%, but this 80 will not be the value that we will be using in the mathematics. As we all know, we have to divide this by 100 to get the actual value. So I will convert it equal to whatever is value. Either you can select by mouse or you can select by keyboard. So whatever is that value in that particular cell, divide it by 100, press tab. Now 0.8, this will be the value we will be using in our actual calculations. Afterwards, there is fuel oil cost. Fuel oil cost, I will simply use a notation C fuel. It is 45,000 and rupees per ton. Okay, next thing. Now somebody might have a doubt ki we can use subscript here. We can make it more technical. So what you can do, double click whatever is the cell value, double click on the cell, then you can select that particular text. You can go to home tab, go to font option, click subscript. Okay, so now your notation will seem more technical. In the same way, if you want, you can convert this in the subscript also. Remember, Excel will not care about this. It is only bothered about these numerical values and the commands that we provide to it. As long as our mathematical commands are good, it does not care about these two particular columns. They are for our understanding. Then next one is calorific value of fuel. So GCV of fuel, I will use same symbol GCV, 10,300 kilocalorie per kg. Afterwards, surface temperature before insulation. Now there will be two scenarios, temperature before insulation and temperature after insulation. So I will call it as TS1. So its value is 170, unit will be degree Celsius. It is up to you if you want to make this degree symbol superscript or not. Sorry, superscript, it will be there. Yes, so it will look like this. Then surface temperature after insulation. Now I will save my time in writing this text. It has already provided me, Excel has already provided this suggestion. So I will now simply press enter. The same text has been replicated. I will double click. I will select this before. I will delete it and then I will write after insulation. So I will indicate the temperature after insulation by symbol TS2. It is 65 degrees Celsius. I will copy and paste. Then the next entity, it is ambient temperature. So I'm going to use symbol TA for this. Ambient temperature is 25 and it is degrees Celsius. So I will copy and paste. Then working hours of the plant. Working hours, I will simply use a simple symbol H per year because this is 8,000 hours per year. These many hours the plant is functioning. Again, you can convert this in the subscript. Choice is yours. It looks a bit professional. Now, your given data has been sorted. Now we will proceed with the solution. I will keep this mathematics in front of you all the time so that we are not confused with any formula or step. Okay, now the beauty of writing the program in Excel is that now if you change the parameter, still the final answer will automatically change. That we will see afterwards. Now we will go towards the solution. I will suggest you leave some space between the given data and solution. Insert a simple row. So that will make your table look more readable and more appealing. The clutter will be reduced. Okay, solution. So first of all, we will analyze existing system. What is the current status of the system? We will calculate current surface heat loss, current fuel loss, current monetary loss, loss in terms of money. So first of all, surface heat loss. Existing in the sense, when we say existing system, which means we are talking about before insulation. Okay. Now every time I cannot keep extending the column, so now I will press Alt and enter. So it will take that before insulation text on the next line in the same cell. Surface heat loss. It is the first case, initial case, hence S1 will be the symbol. The formula will remain same. The only difference is that in this formula now instead of TS I will use TS1, the first temperature for first case scenario. So my mathematics is clear to me. Actually, I will suggest that students should first of all do the hand calculation of the entire problem. They should arrive at the final solution. Then they will be able to compare the output from the program with the output of handwritten calculation or manual calculation. This process is called as validation of the answer or validation of the program, because program is as good as the programmer only. So if the programmer knows the logic correctly, then only program can function appropriately. Okay, I will simply arrange my data properly. Okay, all the quantities are available with me. Now I can calculate S1. I will tell now Excel that this is my formula, but I will have to type it. So equal to, I will open a bracket, the first bracket. So 10 plus. Now I need to create a bracket for TS minus TA. So opening a bracket. You can see the color of both the brackets is different. The first one was black, second one is red. Now TS minus TA. Now Excel doesn't know which one is TS, which one is TA. We have to tell it. So now I will select TS, but I am going to select TS1. Again, this text is not useful to Excel. This text has been written for my convenience. So the value I have selected, the value which is there in the cell C18 will be my TS1 minus TA. Yes, I know this is my TA. Now I will close the bracket. You will observe that when I will now close the bracket, it will highlight the corresponding bracket. If this is the second bracket that I am closing, then second bracket will be highlighted. For a split second, it is highlighted. TS minus TA upon 20. Remember, in this mathematical formula, the 20 has been divided to the bracket of TS minus TA only. It has not been divided to 10. Hence, you have to be very careful with your mathematics. Then I will close the first bracket. So numerator or the first term is done in this equation into once again TS minus TA. So now I will tell TS1 minus, sorry, okay, this is okay. So this is TS1 minus TE. Okay, so my term is sorted. 2501.25 is my answer. Actually, this is the same answer from my hand calculation also. Unit of this S1 is kilocalorie per hour per meter square. Okay, this is again for our convenience. Second one, we need to calculate total heat loss. This total heat loss HS is actually calculated as a product of surface heat loss and surface area. So first of all we need to calculate the surface area. So I will simply cut this and paste it here. So surface area of pipe. Now remember one thing, again you should have real life understanding of the systems. Before insulation, that pipe diameter is 100 mm. After insulation, thickness of insulation is 65 mm. So final diameter of the pipe will be more than the initial diameter. Hence we need to first of all calculate first area A1. This will be surface area and not cross-sectional area. Hence its formula will be pi dl. So we will write it equal to pi. You can also use the value 3.14, but I will suggest you don't go with that. Let Excel take care of it. So pi is an inbuilt function in the Excel. Its value can be close up to 15 digits, accurate up to 15 digits. Hence I will open the bracket and close the bracket. Pi function does not need any argument or variable. It is a very simple function. So pi, then diameter of the pipe is known to me. It is d. But no, which one to take, mm or 0. In meter? Area is in meter square, so we have to take diameter in meter. So pi d into length of the pipe, it is known to us, yes, tab. Area is obtained in meter square. You can reduce the decimal places as per your choice by increasing the decimal or decreasing the decimal. So 31.42 is the area. Now total heat loss, this is my HS1. Now I know that it is equal to S1 into A1. So equal to S1 multiplied by A1. Tab, the unit of HS1 is kilocalorie per hour. Remember, we have multiplied S1 by A1, hence meter square unit will be absorbed. So I will press delete and then I will press enter. HS1 is calculated. I can adjust its decimal places up to 2 or 3 as per your choice. Then next quantity is equivalent fuel loss. Symbol will be HF, but in the first case, hence HF1. Formula is HS multiplied by hours of operation divided by GCV into boiler efficiency. So equal to, I will first create the numerator. So HS, it is available with me, into hours of operation. I don't care how many hours are there because they can be different for different plants. Hence, we are more concerned with the cell values. Hours of operation now divided by, I will again open a bracket for denominator. GCV of the fuel 10,300 I have selected into boiler efficiency. Again, there are two values available, but I know I have to select 0.8. Now I will close the bracket. My equation is complete. I will press tab. 76290.375 kg per year is the fuel loss. Then next one is annual heat loss in monetary terms. I can simply call it as cost per year, whatever you like to call it. And then this is for the first scenario, hence 1. Now how do we calculate that? Simply whatever is fuel getting lost multiplied by the unit cost of fuel. But the cost of fuel is given in rupees per ton, while the fuel loss is expressed in this thing, kg per year. So that's why I have to convert either this into ton or I have to convert this into rupees per kg. Anything will do. So anyways, I have to divide this by 1000. So equal to this divided by 1000. Well, now it is converted to ton. So now I can multiply it with the cost of ton, rupees per ton. Then, so now it is showing me that due to absence of insulation, this plant is actually losing 34,33,000 rupees per year. That's a very huge amount. This is what we have obtained from our analysis. You can check this answer with the help of hand calculation also. Now we will analyze the proposed system. Analyze proposed system. Alt or enter, then which means after insulation. Okay, what I will do, I will simply, because steps are going to remain same, so I will simply copy this text. I will not copy symbols or equations. For your reference, I will keep this mathematics in front of you. So surface heat loss, S2. Now remember, do not copy these equations because they are related with the cell number. Otherwise, Excel will make a mistake. We have to create equations once again. S2 will be equal to 10 plus TS2 minus TA upon 20 into TS2 minus TA. So equal to 10 plus TS2 minus TA upon 20, close the numerator total bracket, into again TS2 minus TA, tab. Again the unit will be kilocalorie per hour per meter square. It is immediately visible here that the value of S2 is 480 while the value of S1 is 2500, which means because of insulation there is a drastic reduction in the heat loss. Then we will calculate surface area of the pipe, but this will be A2. Now remember, the diameter of the pipe which is given to us, we can call it as D1 because it is pipe diameter, and this will be before insulation. In this case, we are going to need a second outer diameter of the pipe, which means after insulation. So I will insert one cell here, pipe diameter after insulation. So it will be called as D2. So naturally, the D1 will be added with thickness twice, and then only you will get the outer diameter. So equal to whatever is the value of D1, I will search for that value. Where is it? It is at the top of the table. So D1 in meter plus 2 times the thickness is to be added, or thickness is to be multiplied, but also the thickness has to be in meter. We have not yet converted that in meter. So I will press escape now. I will insert one row here. Again, I can convert this in meter. I need to simply divide this by 1000. So equal to this value divided by 1000, tab, it is in meter now available to me. So I will get back to D2 equal to whatever is my value of D1 plus 2 times whatever is thickness of insulation. So the value of this D2 is now available with me. So surface area of the pipe after insulation, so equal to pi into second diameter into length will remain same, hence length, tab. So 72.25 is the area of the pipe after insulation. You can adjust the decimal places as you like. Okay, then total heat loss. So HS in the second scenario, HS2 equal to whatever is S2 into A2, tab. So this is actually kilocalorie per hour, not meter square, because already area has multiplied the S2 quantity. So enter. So HS2 is now actually 34,000. Now in this case, what we observe here is that even if the pipe diameter has actually increased, but surface heat loss has reduced from 78,000 to 34,000, which indicates effectiveness of the insulation. So equivalent fuel loss, HF in the second scenario, we have the formula HS2 into hours of operation divided by GCV into boiler efficiency. So that is equal to whatever, opening the bracket, whatever is HS2 into hours of operation, we know how many are there, then divided by GCV 10,300 into efficiency of the boiler. We will take not 80% but 0.8. So tab, this is HF2, it is in kg per year. Annual monetary heat loss, C year 2. So now this is equal to HF2 multiplied by, because HF2 is in kg per year, we have to convert this into ton only, then and then we can multiply it with the price per ton. So now I will press tab. So now it is showing 15,284. I will click on that cell, then I can go to my currency mode. Yes, now it has been converted to rupees, 15,15,284. This much money is getting lost piece per year after insulation. Remember, insulation will not make surface heat loss equal to 0, but it will minimize the heat loss drastically. So now we can calculate saving in fuel per year. Okay, so how will we obtain this? We can simply obtain this by HF2 minus HF1. Again, Excel will not understand this formula because I have not inserted equal to sign before it. I did it just for my understanding. So equal to HF2 minus HF1. Sorry, my mistake. It should be HF1 minus HF2 because HF1 is higher and HF2 is lower. So equal to initial fuel loss minus final fuel loss kg per year. Due to insulation, 42,000 kgs of fuel per year will be saved, and monetary savings per year. So how do we calculate that? Whatever is cost in the before insulation case minus cost after insulation. So every year, due to this simple insulation, the plant is going to save 19 lakh rupees, which is a huge saving. But this saving will not come free of cost. The plant will need to install the insulation. For that purpose, plant is going to incur material cost as well as manpower cost. So we need to take that into account while calculating the payback period. So investment required for insulation. Now this investment will need material plus labor. This can be obtained from any supplier of the even the plant has their trusted suppliers. They can tell you about this cost. Again, symbol is not needed right now because now we are at the end of our analysis. So investment, let us say the particular supplier is charging, let us say 2500 rupees per meter square of insulation. Now what area will be considered in this? Not the first area but the second area which is going to be created after the insulation. So A2 will be considered. Investment required for insulation, because I am still talking about the same entity, so I will merge this cell. Okay, so if it is 2500 rupees per meter square, so total investment will be equal to whatever is unit rate multiplied by whatever is the area to be insulated. I will press tab. This is rupees, only rupees. So approximately, if I go to my currency, even before that I can realize it is 1,80,000. I will confirm it. Yes, it is 1,80,000 rupees is the cost needed for this. So now I can calculate payback period. As we know, payback period is nothing but investment required for that initiative divided by savings accrued. So that will be equal to, this is my investment 1,80,000. I will divide it by savings accrued because of that investment or because of that energy conservation measure. So this answer I will be getting in years. As I can see, 0.09 years will be required to take my money back, to recover my invested money. If I want this in terms of months, this is equal to this one into 12 months. So 1.13 months. In 1.13 months, all my invested money will be recovered. I will adjust the decimal places for these two quantities. Yes, or even if I want it in days, I simply have to multiply this by 30. So in 33 days or 34 days approximately, my entire money will be recovered. So it is a win-win situation for me, because insulation will help me to save a tremendous amount of fuel, a significant amount of money, and this insulation can have a life of up to 3 years, which means that is going to pay me for 3 years. So this is how you can analyze the parameters with the help of Excel program. You can consider it as a tutorial to start with the Excel analysis. Now the beauty of this particular program is that it is immediately visible to you. One more thing that I will suggest, like I said in the beginning, if some plant has some other parameters, some other set of parameters, then same program can be used for that. For example, let us say I select this and I create a separate table for a plant number 2. I will copy this and I will paste it here. So this is my analysis for my second plant. I will just select all the cells and then I will create partition properly. Yes. Let us say in the second plant, the diameter of the pipe is not 100 mm, but it is 250 mm. So now you can see, first of all, the values are same, but now as soon as I change the diameter in the top, immediately the values of surface heat loss and everything else will be changed. So 250 mm, as soon as I change it, the first change will happen in this unit conversion. Meter is converted. All the other given data, let us say it remains same. You can see that surface heat loss will remain same because it is independent of diameter, but A1 will change. That's why HS1 will change. It has changed from this first value of 78,000 to 1,96,000. So the cost or the annual monetary loss, previously it was 34 lakh, now it is 85 lakh rupees. It's a huge change. And then in the second case, when we have applied the insulation, due to insulation, previously the pipe diameter was increased up to 0.23 meter. Now it will increase up to 0.38 meter. The surface area will also increase, as you can see here. And the saving, previously it was, sorry, the monetary loss in the second case, previously it was 15 lakh rupees, now it has increased up to 25 lakh rupees. So the saving which is obtained, it is 60 lakh rupees. Previously it was 19 lakh. If the cost of insulation is same, then my investment actually increased from 1,80,000 to 2,98,000. Then the payback period is, again, actually it has reduced down because the pipe diameter has increased, and so it has affected this payback period. So in 18 days my money will be recovered. Now you can observe it has taken us only a minute to do the second analysis because our program was appropriately written down in the first attempt itself. So that's the beauty of it. If some plant is working for 300 days a year, so operating hours, if they become equal to, I will just give me a second, I will zoom it in. So equal to 24 hours it is working, but it is working only for 300 days. How is it 300 days? There are 365 days in a year. If we consider 52 weekly offs, either Saturday or Sunday, then 52 Sundays, so those are eliminated. And then there are national holidays or Dashera, Diwali, Eid, Christmas, Gandhi Jayanti, 15th of August Independence Day, or 26th January Republic Day. Then in that case, those holidays are considered, so it comes out to be 300 days. So I press tab now, 7,200. So if again this is changed, then again the entire equation will change. In the next video, I will show you that how to represent all these entities in the graphical form. I hope this tutorial is useful to you, and more importantly, the core purpose of making this tutorial is to help mechanical engineering students to avoid the fear of programming. That this is how the logic of the programming flows for any program. You should know the basic mathematics clearly. If your mathematics is clear, then you can write that program, and such an analysis is tremendously useful. This can be even used by the plant personnel who is a layman, and he can use this solution. I hope this is useful to you. Thank you.